predicting the relative acidity of a binary acid. Well, if you remember what an acid is something that's going to donate a proton, and that proton is bound to the rest of that molecule. There's a bond with a bond strength, and if you're going to donate that proton, that bond energy has to be broken. So if you were to have a very weak energy, a very low energy number, then it's going to more readily break off and you're going to have a stronger acid. If you the more often that you donate the hydrogen, the stronger your acid is going to be. So one of the ways to predict acidity when you have a binary acid is look at the bond between the hydrogen that's going to be donated and the remainder of that acid. And the weaker that bond is, the more likely that you're going to have a strong acid. It's going to be stronger and stronger. Another thing possible that you could look at is whether it's a polar bond or not, the strength of the polarity, which has to do with the electronegativities of the hydrogen and whatever that hydrogen is bound to. And you can predict that the more polar that bond, the stronger the acid can be. So let's look at some examples. All right, so right here I've just got a table of bond enthalpies, and we're only interested in hydrogen and something else. And you could look up something specific if you had a specific atom that you're looking at that hydrogen is bound to, and the Aleks data tables would be a good place to look for those bond enthalpies. So the weaker the bond, the stronger the acid's going to be. Another rule of thumb is as you drop down the column, those enthalpies are going to drop also. So you're going to get a weaker and weaker bond as you go down the column, which means you're going to get a stronger acid. So the second picture I gave you was the bond polarities. These are electronegativity numbers. So if you have like something like fluorine, which has a 4, hydrogen 2.1, you'd subtract those two, and that's the strength of that ionic character, or the polarity of it. And the stronger the polarity, the more likely you're going to have a strong acid. So here is our example. They said that you have silicon tetrahydride, or SiH4, in an aqueous solution. So is there going to be a character of an acid there? And what do you predict would have a larger case of A? Well, we want something in that same column. I would look there first, in that same column, that's going to be lower than your silicon, that's going to touch with that hydrogen, that's going to be lower, and the lower you can get, the weaker the bond will be, and the more likely that it would donate that hydrogen and become acidic. So my guess, my prediction, would be that it would be the next one in line. So what is under silicon is germanium, so GeH4. So I would call this a hard problem, but I hope that this helps some.